This video is about how we can find the maximum and minimum values of trigonometric functions in a quick and easy way. So, for example, I'm looking to work out what are the coordinates of these maximum points and what are the coordinates of these minimum points, and I want to try and do that as quickly and easily as I can just by looking at this equation. We'll come back to this example in a few moments. First, let's remind ourselves of what the sine and cos graphs look like. So first of all, with the sine graph, we know it starts at 0 and goes up to a maximum coordinate of 1 when the angle is 90 degrees. It then goes down to 0 at 180 degrees, then down to its minimum point of -1 when x is 270 degrees, and then back up to 0 at 360 degrees. So we know it has a maximum coordinate of 91 and a minimum coordinate of 270 -1. And we know that the sine graph is going to repeat every 360 degrees. We've got another cycle of 360 degrees here, and there's another one down here. Every 360 degrees we'll have another cycle, which means that I can find other maximum coordinates by just adding 360. So 90 plus 360 is 450. That's this coordinate, this maximum point here. I could find another one by adding another 360. 450 plus 360 is 810. That would be another maximum coordinate over here. And similarly with the minimum coordinates, I can find other minimum coordinates by adding 360. 270 plus 360 is 630. That's this minimum coordinate here. Or I could always subtract 360 as well. I could do 270 minus 360. That gives me this minimum point here. So, key facts about the sine graph. It has a maximum of 1 when x is 90. It has a minimum of -1 when x is 270. And it repeats every 360 degrees. Cos graph next. So let's remind ourselves of the basic cos graph. It starts at 1 when x is 90. Sorry, when x is 0. So starting with x being 0, cos is 1. Then it goes down to 0 at 90 degrees. Goes down to -1 at 180. Up to 0 at 270, and then back up to 1 at 360. So it has a maximum coordinate of 0, 1. That's this point here. And it has a minimum point of 180 -1. That's this point here. And again, we know that the cos graph is going to repeat every 360 degrees, so we know we can find other maximum points by adding 360 or subtracting 360. Similarly, with the minimum coordinates, we can add or subtract 360 to work out other minimum points. So, key facts about the cos graph. It has a maximum of 1 when x is 0. It has a minimum of -1 when x is 180. And again, it repeats every 360 degrees. One thing to be on the lookout for. If we have a minus in front of the function, like I do here, got this minus in front of the cos. Remember, that that is a reflection in the x-axis. You can see I've drawn that onto my graph here in orange. I've just reflected the cos graph in the x-axis. The effect then is that all of those maximum points I had before, they've become minimum points now. And the minimum point that I had before has now become a maximum point. So be on the lookout for that negative in front of the function, because what that does is that's going to swap the maximum and the minimum around. So the sine graph will have a minimum of -1 when x is 90, and it will have a maximum of +1 when x is 270. For the cos graph, we'll have a minimum of -1 when x is 0, and a maximum of +1 when x is 180. So just be on the lookout for that negative in front of the trigonometric function. Right, let's apply that to a few examples. So here we've got the graph or the function of y equals 2 sine x plus 7. We want to find the maximum value of y. So we know the maximum that sine can be is 1. So we're going to have 2 times 1 plus the 7, which is 9. And we know that that maximum happens with the sine graph when x is 90. So we'd have the coordinate of 99. We know the sine graph has a minimum value of -1. So we'll have 2 times -1 is -2, plus the 7 is 5. And we know that that minimum is going to happen when x is 270. So we'll have the minimum coordinate of 275. Second example, we've now got the trigonometric function of y equals 3 cos x minus 40 minus 1. We want to find the maximum value for part A. So we know the maximum value of cos is going to be 1. So we've got 3 times 1 minus 1 is 2. So the maximum value of this trigonometric function is going to be 2. And we know that that is going to happen when the inside here is equal to 0. So x minus 40 is going to equal 0. So x is going to be 40. So we have a maximum turning point of coordinate of 40, 2. So just to be absolutely clear, what I'm saying here then is if x is 40 degrees, we will then have 40 minus 40, which would be 0. Cos of the 0 will be 1. 3 times that 1 is 3, minus the 1 is 2. Next, let's find the minimum value that this function can take. We know the minimum of cos is going to be minus 1. So we'll have 3 times minus 1 is minus 3. Minus the 1 on the end there will be minus 4. So that's the minimum that y can possibly be here. And we know that that's going to happen when this inside is equal to 180. So that's going to be when x is 220. So we have a minimum turning point of 222. Next example. Now, first thing to point out here, look, is we're in radians. So let me just adjust my key facts here to account for the fact that we're in radians. So 90 degrees is the same thing as pi over 2 radians. 270 degrees is the same thing as 3 pi over 2 radians. 360 is 2 pi. 0 is still 0. 180 is pi. And 360 again is 2 pi. Now, the other thing to point out here is, look, we've got a minus in front of the sine function. This minus here is going to flip my maximum and minimum values around. So I need to be careful about that. Right, so the maximum value of y. So the maximum that this can possibly be is going to be plus 3. Then we'll add the 2 to that and get 5. That's the biggest that that can possibly be. When is that going to take place? Now we know that usually the sine has a maximum when the inside is equal to pi over 2. Let me just repeat that. Usually the sine graph has a maximum when the x is pi over 2. But that minus flips things around in this case. And actually we're going to get a maximum now when x is 3 pi over 2. So, when is it that this is equal to 3 pi over 2? We'll add the pi over 6 to both sides here. So we'll have 3 pi over 2 plus pi over 6, and that's going to give us 5 pi over 3. So this is our maximum turning point. 5 pi over 3, 5. Next, for part C, we want the minimum value that y can be. So that's going to happen when we have a minus 3 from here. So we'll have 2 minus 3, which will be minus 1. So that's the minimum that this function can possibly be. When is that going to take place? Well, usually we have a minimum when x is 3 pi over 2. But remember that negative in the front here flips things around. And so actually I'm going to have a minimum now when the x is pi over 2. So this thing here needs to equal pi over 2. We'll add the pi over 6 to both sides. So pi over 2 plus pi over 6 gives us 2 pi over 3. And so our minimum turning point will be 2 pi over 3 minus 1. Fourth and final example for this video, and we're going back to that graph we had right at the start of the video. And we want to work out what the coordinates of these turning points that I highlighted at the beginning of this video. So, notice again, we've got this negative in the front of the cos function, so that is going to flip things around. Right, the maximum value that y can possibly be. That's going to be 7 plus 2, which is 9. When we need to find 3 different values when that maximum is going to occur. Usually with cos, the maximum happens at 0, but that negative is going to flip things around. So actually my maximum is going to happen here when x is either 180. So when this thing on the inside here equals 180. But I could also find other values, and this question does want me to find other values, by adding 360 to that. So I can do 180 plus 360 is 540. I could add another 360 again to get 900. Or I could always subtract 360 as well. I could do 180 minus 360. Then we're going to subtract this 50 from each of these values. So minus 180 minus 50 is minus 230, 180 minus 50, 540 minus 50, and 900 minus 50. Then we're going to times everything by the 3, then we're going to divide everything by the 2. So just bear with me while we do that. We'll times by 3, divide by 2. And I've actually found 4 coordinates here. I've found the coordinates minus 345, 9, 195, 9, 735, 9, and 1,275, 9. So these are 4 possible coordinates when this graph would have a maximum. Now let's do the minimum values. So the minimum values are going to happen when we do 7 minus 2, which is 5. The minimum values are going to take place when the 2x over 3 plus 50 equals, usually the cos graph has minimums at 180. But in this case, because of the negative, we know it's going to have minimum values when x is equal to 0. Or 360, or 720, or minus 360. And then again, following the same process as before, we're going to subtract 50 from all of those. Then we're going to times everything by 3 and divide everything by 2. And so we've got 4 coordinates of minimum turning points here. We've got minus 615, 5, minus 75, 5, 465, 5, and then 1005, 5. And just to show you, let's go back to that graph we started right at the beginning with, and you can see those are the actual coordinates of the turning points we highlighted right at the beginning of the video. So that is how you can find the coordinates of turning points just by looking at the equation and remembering these key facts about the sine graph and the cos graph, and then just remembering how to adapt them ever so slightly if you're working in radians, or if there's a negative in front of the sine or cos function.